Good afternoon, sir. I am M. Manoj Kumar from Triple Section A. Today I am going to discuss about a topic fitting a straight line for CAA 2. First, what is a curve fitting? The mathematical relation between two variables can be expressed as simple algebraic equation is called curve fitting. The most common method used for fitting a curve is the method of least squares. Method of least squares. The method of least squares states that the sum of the squares of residue are minimum. It is nothing but difference between observed value and expected value. Then we show that all are positive. Let us consider y1, y2, y3 and so on yn are the functions corresponding to the values of x, that is x1, x2, x3 and so on xn, which satisfies the given curve. For example, y is equals to f of x, where y is equals to a plus bx, y1 is equals to a plus bx1, y2 is equals to a plus bx2 and so on, yn is equals to a plus bxn. The residues of the ith term is yi is equals to a plus bxi. Let s of a, b be the sum of the squares of the residues. It is difference between observed value and expected value. It can be written as the sum of the squares of the residuals. S of a comma b is equals to summation of I is equals to 1 to n of y1 minus a minus bxi whole square, that is represented as equation 1. The method of least square to minimize the values of s is fitting a straight line. Now fitting a straight line, let us consider y is equals to a plus bx. Be a straight line fitting to the given data from the equation 1. To minimize the values of s, then we differentiating with the equation with respect to a and b partial a. Then the equation 1 becomes, we get to minimize the values of dx. Now dou s by dou a is equals to 0 and dou s by dou b is equals to 0. Now dou s by dou a, we are partially differentiating the s of a comma b equation, and we are equating it to 0 with respect to a. We are differentiating it with respect to a, and it becomes dou s by dou a is equals to 2 into summation of I equals to 1 to n y1 minus a minus b yi minus a minus bxi of minus 1 is equals to 0. That becomes minus 2 into summation of I is equals to 1 to n of yi minus a minus bxi is equals to 0. And it becomes yi minus a minus bxi is equals to 0. Then yi is equals to a plus bxi. Then summation of y is equals to a plus b summation of x. This will become summation of I is equals to 1 to n is y of I is equals to summation of I equals to 1 to n a of I plus b into summation of I equals to 1 to n xi, and it will becomes summation of I equals to 1 to n yi is equals to n into a plus b into summation of I is equals to 1 to n xi. Then the equation becomes summation of y is equals to n into a plus b into summation of x. And equation 1, when the equation 1 is partially differentiated with b with respect to b, it becomes 0. Then the equation becomes 2 into summation of I is equals to 1 to n of yi minus a minus bxi into minus xi is equals to 0. That will becomes minus 2 into summation of I is equals to 1 to n yi minus a minus bxi of xi is equals to 0. Summation of I equals to 1 to n of yi minus a minus bxi of xi is equals to 0. Then the equation becomes summation of I equals to 1 to n yi into xi minus a into xi minus b into xi square is equals to 0. Then it will be, then the equation be splitted. Then the summation of I equals to 1 to n of xi into yi is equals to summation of I equals to 1 to n of axi minus summation I is equals to 1 to n of bx square is equals to 0. Then the equation will be summation I is equals to 1 to n of xi into yi is equals to summation of I equals to 1 to n of a into xi plus summation of I equals to 1 to n of bxi square. The, the general equation is summation of xy is equals to a into summation of x plus b into summation of x square. This equation is represented as third equation, equation 3. The two second and third equations are called normal curves. By solving these two equations, we get the values of a and b. Then substitute these two in the given straight line a plus bx. We get the general equation. Again, differentiating equation 2 and 3 with respect to a and b partially, we get second order differentiation. Then these two equations gives the values of a and b as zeros. Therefore, there is no fitting a curve for the values of x and y. Example problem. Examine y is equals to a plus bx to the following data. Fit the straight line. The x value and y values are given in the table. To solve this problem, we need to know the above formulas. Now, solution for this problem is given that if y is equals to a plus bx be a straight line, to fitting a data by the method of least squares to the following normal curves, the formulas are summation of y is equals to n into a plus b into summation of x, and the another formula is summation of xy is equals to a into summation of x plus b into summation of x square. This table will be calculated by using Casios, and we get the values of summation x and summation y and summation x square and summation xy for the above, to substitute in the above formulas. Now summation of y is equals to n into a plus b into summation of x. N means the number of intervals in the table they given. The number of intervals in the table they are given is 7. Therefore, summation of y is equals to 0 and summation n is equals to 7 and summation of x is equals to 2 minus 2. Summation of xy is equals to a into summation of x plus b into summation of x square. This is the second formula for normal curves. And the summation of xy is equals to 0, summation of x is equals to minus 2 and summation of x square is equals to 56. Then by solving these two equations we get a is equals to 0, b is equals to 0. Then y is equals to a plus bx, that is equals to 0. Thank you, sir. Thank you.